Good evening. Let's have a little conversation about today's team test. And let's walk through what a good process on this team test would have looked like, or what I would have wanted you to do during this team test together. So first, we read through the problem. So again, did you know that President Garfield, our 21st president, liked to dabble in math? Okay, that's wonderful. Rhetorical question. So in fact, he provided a proof to the Pythagorean theorem that is similar to the way we developed the theorem in class. So in all actuality, there are entire books devoted to the subject of the Pythagorean theorem. We are only being subjected to two demonstrations, one in which I rotate and translate triangles in order to make a square and show that the square areas create a squared plus b squared equals c squared. And the other in which I wanted you to explore through is using the trapezoid in order to prove that a squared plus b squared equals c squared. And this is President Garfield's take on that proof. So just as we rotated and translated a right triangle with lengths A, B, and C in problem 2-109, so did Garfield to produce the trapezoid. So the first question was, if points V, W, and X are on a straight line, explain why ZWY is a right angle. Okay, so I am saying it is right. Explain why it is right. Okay, once we've explained that, so there's one answer we need to come up with. Explain why ZWY is right. Then, using our understanding of areas, algebraic skills, and reasoning abilities, show how this picture proves the Pythagorean theorem. So now first, let's explain why ZWY is a right angle. So points VWX are on a straight line. Okay, so this word straight is what jumps out at me. And in fact, if I'm supposed to know an angle measure on something straight, the only thing I know for certain in straight angles is that they are how many degrees? 180. And I'm going to pause here for a second and suggest heavily that everything I write down at this moment, you should be writing down. You should take notes as to how to prove number one. Be very helpful in class tomorrow. So again, 180 is a straight angle. Part of that angle I'm claiming is 90 degrees. So what does that leave? What does that tell me? That tells me that this angle here and this angle here, when I add them together, or let's be very specific about it, angle VWZ plus angle YWX need to equal 90 degrees. If I have 180 total and I'm telling you this is 90, I want you to tell me why. We actually need to show why these two are 90. So let's think back to some of our group problems in which we talked about the angles of triangles. So this triangle here, ABC, triangle WXY, was rotated this way, and then translated up here to make VZW. Okay, and how do I know this? So rotated and translated tells me in the problem. Okay, President Garfield did the same thing in the picture on the right. Rotated, and then translated. So these two triangles are the same as each other. The shape is the same, which means this angle here and this angle here are the same. And this angle here and this angle here are the same. Now, when I take blue plus pink plus 90 and add it together, I should get 180 degrees. If I take blue plus pink plus 90 here, I should get 180 degrees. And right here, I've got blue plus pink plus 90 equaling 180. Now, have I proved why that's a 90-degree angle? To myself, yes, but now I have to figure out how to write it. So, because triangle WXY was rotated and translated to create triangle ZVW, I know that all the angle measures and side lengths stayed the same. Okay, symbol, therefore, angle X, Y, W, I'm going to highlight that in blue, therefore angle XYW, remember our symbol, is congruent to angle ZWV. ZW.
With the sky blue sky, this rotten time wouldn't seem so bad to me now.
ZWV. Blue. And XWY, which is one of my pink angles, is congruent to WZV. Which is also pink. So now, if I come up here to my original thought, I know that the blue and the pink together have to be complementary, then VWZ, when added with, so pink, when added with blue, need to equal 90, because these two are equal to each other. There was a rigid transformation. Okay, so to complete the thought, because triangle WXY was rotated and translated to create a triangle ZVW, I know that all the angle measures and side lengths stay the same. Therefore, these two angles are congruent and these two angles are congruent, making, completing my thought, scroll down a little bit, making angle VWZ and angle YWX complementary, and angle VWZ plus angle YWX plus angle, and we're going to bring this one ZWY equal to 180. Okay, now this is my explanation on why this should be 90 degrees. Yours does not have to be, would not have to be this way verbatim, but this is what I see, and that's what you need to ask yourselves every time you're doing these problems is, what do I see? And you need to be able to verbalize what you're seeing. Okay, now on to the proof. Hold on a second, having difficulties. And we're back. Now, on to the proof of how does using area, algebra, and reasoning abilities, how does this picture, and let's get rid of some of this information here. Okay, I would say if you're doing the proof, don't erase, never erase. However, so you can see what I'm doing to stay consistent, I'm going to get rid of some of these things. Okay. So, how does this picture prove a squared plus b squared equals c squared? Not really prove it, but how, when we use the words proven, can I start with the things in this picture that I know and get to here, get to the Pythagorean theorem? That is what this problem is asking me. So, what things do I know? Well, let's look at areas. What areas do I know? Just not even based on the picture, but off the top of my head, I know the area of a triangle. It's equal to 1/2 base times height. I know the area of a parallelogram. It's equal to base times height. I've also talked about the area of a trapezoid, which is 1/2 height times b1 plus b2. So these are some things I'm bringing to the table. I know I have a blue sheet in my binder that I could have gotten out during the opportunity at any moment and worked on. So, what is it about these areas that can help me get to Pythagorean theorem? Okay, so I've got 3 triangles. Again, this is what Mrs. Richardson sees. I've got 3 triangles. 2 triangles I know are congruent because one was transformed to make the other. So I've got two triangles, 2 1/2 base times heights plus, okay, a third triangle plus a base times height. That's not the same as the other 2, so I can't group it. So another 1/2 base times height. So 3 triangles equal to a trapezoid. 1/2 height times b1 plus b2. Okay, so this is what I got going on. I got a triangle, 2 triangles, plus 1 triangle equal to a trapezoid. Woo, there's my picture. Okay, now, let's use information from the picture in order to, so all these b's and h's can be discerned. So what are my triangles? Base and height. We've got A and we've got B. Okay, we have A, B's, and C's. That's all we have to work with. So in this triangle, I have 2 times, and I'm going to start, instead of doing the half, I'm going to use BH over 2, just because it will look less complicated. And again, make sure you're taking notes on this stuff. And bring these notes with you to class tomorrow. I will not be bringing out this video tomorrow. So 2 times 1/2 base times height. So 2 times my base and my height. So 2 times A times B, base times height, all over 2. There's one set of triangles. Plus, now we need this triangle here. This triangle's base and this triangle's height are both C's. So what I'm going to do here is say base C times C divided by 2. Okay? So 1 triangle plus 2 triangles plus 1 triangle equal, now I'm going to pull myself out and look at the whole entire trapezoid. And again, for the trap, oh, I erased all that stuff. Whoops. For the trapezoid, I'm going to do this. This was a triangle. Okay? I'm going to do it all over 2 to help it make sense. So now, I've got the height. The height is here. The height is A plus B together. Okay? Combine them. You can do that. You can take 2 things and add them together. And once you know what they are, you'll actually get one whole number. So height times base 1 plus base 2. A plus B again. Oh, look at that. All divided by 2. Okay? So again, this looks nothing like a squared plus b squared equals c squared. However, it should start to pop to me that perhaps I can get a squared plus b squared equals c squared from something that looks like this. So this, in essence, lets me know I'm on the right track. How do I really know I'm on the right track? Let's start simplifying, because what we do, we like to simplify in mathematics. So I'm going to get rid of that. Simplify that. I've had AB. C times C becomes C squared. Oh, goodness gracious. And let's not forget that this is over 2, because this 2 only counts for right there. This is still our single triangle. And this is all over 2 also. Sorry, a bunch of stuff got erased. So we're going to say A squared plus fronts AB less also AB or BA, whatever your preference is, plus B times B is C squared. That is also all over 2. And now this is really starting to look complicated and confusing, because I got some fractions in here, and Lord knows fractions just don't make life nice. So Miss Richardson likes to get rid of fractions, not rid of, just simplify fractions. So I'm going to multiply my entire equation by 2. Why do I pick 2? Because 2 is in the denominator of 2 of my fractions. It is my least or greatest common factor. So 2 times AB, 2 AB. 2 times c squared over 2 just gives me c squared. Oh, that looks a little familiar. 2 times a squared plus ab plus b squared all over 2 just gets rid of that. So I have a squared. If I have ab here and ab here, I add 2 ab's and then I add b squared. I'm seeing it. It's becoming clear. If I subtract 2ab from both sides, so I'm combining my like terms, that goes away, that goes away. Look at the magic happening. Look how fun this is. Yay! C squared is equal to a squared plus b squared. That looks so familiar. Okay, so now, did I just prove using areas? Did I prove using algebraic skills and reasoning ability? Did I show how the picture also gives me the a squared plus b squared equals c squared result? Meaning 3 right triangles, 2 of which are the same as each other, all put together to form a trapezoid, can also show how the 2 sides of a right triangle, when squared, can give me the third side squared. Bring your notes to class tomorrow so we can discuss this problem. See ya.